Ho, ho, ho! It's nearly Christmas! Merry Christmas to all my viewers of DrBiology. I thought it'd be really good to do a video about the science of Father Christmas. So please do enjoy! So, first question, how many children does Santa visit? Well, in 2016, it was estimated there are about 1.9 billion children in the world. Now, he probably won't deliver to all these children, religious reasons, other technical reasons. Maybe he just doesn't like those children. Who knows? So anyway, let's assume he delivers to 31.5% because those are described as Christian. So that's 602 million children. Personally, DrBiology thinks that he would deliver to every child. But for the purposes of science, we're going to stick to the 602 million. It just makes it easier to calculate. Okay, so Santa is a very busy person. He's got 602 million children to see. So we're going to assume a few things. The first thing is, obviously he's going to be very busy after spending a full year making toys and writing his naughty and nice lists. Santa Claus has got to embark on a mammoth task. Okay, so the first thing to say is Santa is going to start at the east. Okay, he's going to start right at the east point, most easterly point. And he's going to start his journey in the South Pacific. His first stop is the Republic of Kiribati, a collection of 32 atolls in the Pacific Ocean. He then travels to do his presence in New Zealand, in Auckland, okay, and then Australia, and then over to Japan, and then you can see it's pretty wiggly waggly all the way across, and that is going to take him 32 hours. There we go. So, yeah, another assumption. We're going to assume that there are 3 to 4 children per home, which is quite high, really. When you look at Western Europe, it's 2.4 children or slightly less. Anyway, so we're going to say that's 172 million homes. Whoa. In 32 hours. So, what is the time per visit if he's got to visit all of these homes? So we can calculate the number of visits per second. So, Santa, can you move out the way? Yo ho ho ho! Yes, I can, DrBiology. Whoa, whoa! There we go. Over there, Santa. So, I did say 32 hours, but I'm going to go with 31 hours because obviously Santa has to go to the toilet, he has to feed his reindeer, and other bits and pieces. Maybe he's needs something to eat or drink. So, 31 hours, and that is 111,600 seconds. Now, if you remember, I said there's 172 million homes, so I'm actually going to convert that into standard form. So it's 1.72 times 10 to the 8 homes. So you divide that by the seconds. And that gives me, or gives Santa, 1,540 visits to each house per second. Per second. Crazy. So Santa is going to have a very quick sleigh. He's going to need his reindeer to ride like the wind. Now, we all know this. It's fact that Santa has his Santa's dust after all. And Santa's dust means that he can travel at phenomenal speeds. So we'll assume that he has to travel 510 million kilometres on Christmas Eve, and that he has 32 hours to do it. Well, we said 31 hours. Then Santa will be travelling at 10,703,437.5 kilometres per hour. So that's about 1,800 miles per second. So putting it into context, he's travelling just under the speed of light. Blink and you will miss him. At this point, it's very interesting to think about the fastest human objects. So, for example, the Apollo command module recorded the highest velocity ever reached for space travel when it entered the atmosphere at 4 times 10 to the 4 kilometers per hour. And in air, it was achieved by the US Air Force's X-15 jet, which was only 7,273 kilometers per hour. So it's pretty obvious Santa's sleigh is not going to be powered by a rocket. Obviously, a rocket-powered sleigh is out of the question. But he may have a way of warping space-time. He could even sit maybe in a small bubble of space himself, or travelling faster than light. Latest thoughts on scientific thought is that he may be using wormhole technology to provide cosmic shortcuts, so allowing him to time travel and get over the constraints of delivering in one night. Another consideration is the reindeer's antlers. A famous professor, Professor Ian Stewart of Warwick University, he said reindeers have a curious arrangement of gadgetry on top of their heads, which we call antlers, and naively assume exist for the males to do battle and to win females. This is absolute nonsense. The antlers are actually fractal vortex shedding devices. We are talking not aerodynamics here, but antler aerodynamics. So he's obviously going to have to carry all his presents and fuel for his journey. Apparently he uses coal as far as we are aware. But I'm pretty sure he's aware of global warming, and we did discuss he might be using wormhole technology, so I'm sure he's looking at his environmental footprint. So let's think about the average weight of the toys, the average weight of his fuel. Let's see how heavy that will be. So average weight of toy, so we're going to say 0.95 kilograms. Obviously some toys weigh more than others, so that's going to be an average. And then we need to think about the number of toys for nice kids. So we did say there was quite a lot of children, 602 million, but obviously a small percentage of those are going to be naughty. So I'm going to take 1% off for kids being naughty. So the other 99% of children, we can then work out how many toys. So that'll be 595,980,000 toys. Average weight of 0.95 kilogram per toy. So total weight, you times the 2, you'll get... Also realising that 1,000 kilograms equals a tonne, so in tonnes I've worked it out as 566,301 tonnes, which is quite a weight when you think basically the sleigh is going to be equivalent to the weight of 183 Saturn V space rockets. Oh, and I forgot the weight of Santa. Now, Santa is usually described as an overweight man, so I'm going to add to his payload, I'm going to say he's about 20 stone. So we can add 20 stone there. Although I might be doing him a disservice. Maybe he's been on a diet and he's doing lots of exercise. So maybe even he has taken up running. That'd be even better. So How does Santa keep going? He's going to have to keep going. He's going to need a lot of fuel, a lot of food. So obviously, as you know, hopefully you already do this. You put out your mince pie for Santa, and you put out your carrot for the reindeers, obviously. He's going to have a bit of a drink as well. He might even have a bit of a drink problem. Who knows? So looking at the average mince pie, which is about 250 kilocalories, he has one in every house he visits, so he should consume about 58 billion calories in just one night. No wonder he is quite a big chap. So he's going to weigh quite a bit, especially by the end of the night. So that we need to add that on to the weight of his sleigh. I just feel sorry for his reindeers. So you're probably wondering how you're going to be able to track Santa's journey. Well, there are two ways. Okay, the first one, my favorite, is the NORAD Tracks Santa website. It allows you to track him across the globe from December the 24th. Okay, and it will be fantastic. You can actually in real time see where he is and how close he's going to be to you. Also, as well, there is Google Earth. So Google Earth also has a Santa tracker as well.